Hi, so in this video, we are going to talk about binomial distribution, and it's really going to just be a lot of how to use your calculator because we need to identify the different variables in the problem and then figure out how to put them into your calculator. So good thing I got my new calculator app. All right, so looking at the notes to start, a binomial probability distribution. So to binomial probability distribution allows us to deal with circumstances in which the outcomes belong to two relevant categories. So, for example, if we're looking at light bulbs and we want to know which light bulbs are acceptable and which ones are defective, there's two choices. They're either good or bad, broken or not broken. Some other sort of, testing, not testing on animals, but, testing populations of animals, which ones survived, which ones died. Or, even being super dramatic, like seatbelt usage, how many people survived accidents with airbags versus no airbags, seatbelts versus no seatbelts. The choices would be, did you survive or did you not survive? So there's two outcomes. Will be a little less dismal in today's examples. So the rules for binomial probability distribution, it has a fixed number of trials. So they're not just doing this forever. We know what n is. We always want to know what n is. The trials must be independent of each other. So for example, I flip a coin, I get heads or tails. That's a binomial probability distribution. I flip the coin again. It doesn't matter what I got the first time. The second trial is independent of the first one because every time I flip the coin, it's a new flip. Something that's not independent, this is also not binomial probability distribution. It's just a good example of what not independent, what dependent would be like if you drew a card and then you put the card in your pocket. Now you only have 51 cards left. You draw another card. So now the probabilities change because you have less cards. So whatever the second event, whatever you draw the second time is affected by what you drew the first time because there's less cards in the deck. So what I'm saying is that's not what's happening here. These are all independent cases. Each trial must have outcomes classified as success or failure. So we need that binomial. We need those two choices as our results. We will kind of read through the problem and determine what a success and what a failure is, because if we are talking about baseball and the pitcher threw a strike or they threw a ball, well, if they threw a strike, that would be a success for the pitcher. So in that example, if we're talking about the pitcher, that's a success. But maybe that's a failure to the batter, right? So it kind of just depends on the perspective. And if you don't follow baseball, don't even worry about it. Like it'll be obvious. It'll typically like state what the success is in the problem. And finally, the probability of success remains the same in all trials. This is going to happen. The probability of these events are not going to change over time. You're going to be given the probability and it's going to stay the same. So really what you're looking for are the middle two, or actually at number 3 is really the one that you should focus on in this. Would each trial, yeah, that's the one we were really focusing on, because number 3 really focuses on the binomial part. Okay, anyways, here we have a formula. Now this formula is a hot mess. I will tell you that right now. Flag this. This is obviously not something you're going to memorize. This is something you're going to have access to for future homework, quizzes, tests, and whatnot. So we have this probability of X happening, and we have this fraction with the factorial. On your calculator, let's just switch over really quick. On your calculator, we can access the factorial button. I can switch over. Oh, activate. Okay, I forgot I have to activate it every time before I share. And now it's closed. Okay, just one second while I open it up, and then I will be able to share it. I think I clicked the right button. I don't know. Like I said last time, if I didn't have malfunctions, you might think I was a robot or something. So here we go. It is opening up for me, and I know you can't see it, but I will be sharing it quickly. Oh, what I clicked was that I was ready to pay. That's why it was getting mad at me. Okay, here I got my side open. So let me jump over so I can share it with you. Why is it getting, it's getting, okay. One more time Zoom and then I quit. Okay, here it is. We're good to go. Voila. Okay, So let's get out of here. So what was I saying? Factorial. On your calculator, you can do the factorial by hitting the probability button. And you'll notice number 3 is that exclamation point. So if I do, let me get out of here real quick. If I want to do 5 factorial, I would do 5. And then I would go to the probability button, hit factorial, and it shows me that the answer is 120 because 5 times 4 times 3 times 2 times 1 is 120. That's what 5 factorial means. If you are using a graphing calculator, you can go to math and then scroll over, and that's where your probability button is. So you hit math first, and then you can scroll over to probability. If you are at home with a graphing calculator and you have not emailed me yet, I do have a file that has these things listed out, and you can just read through it at your leisure. Okay, so that's the factorial button. Let's go back to the problem that we were working on. And you can see that that factorial shows up in the numerator and the denominator. Now, this gets messy because there's factorials, there's fractions, there's a product in the denominator. So actually this whole fraction right here, we could type in a lot simpler by using a very specific button on our calculator called, oopsies, click the wrong button. It's NCR button. I'll just type that out. It's a lowercase n, a capital C, and a lowercase r. That button takes care of this whole fraction. So when we get to an example, I'm going to show you how to access that button. But that button will take care of the fraction, and then we will still have to type in the p to the x and the q to the n minus x. Now, n is the number of numbers, the number of trials, the number of whatever we're talking about. N is the same in this whole class. So n, we'll just say number of trials. It's the same thing like when we're doing mean, same n. In the future, when we talk about n, it'll be the same n. So n is the same in this whole class. X, you might feel like we've talked about x before because we did talk about x bar when we talked about mean, but we haven't actually talked about the letter x by itself before. So x is the number of successes. And so you'll notice it says P is the probability of a success. So P will be a probability, whereas X is that actual number of successes. So if I flip a coin 50 times, flip it. So N is 50. I flipped a coin 50 times. The number of times I get heads, because I'm going to call heads a success. Let's say I got heads 30 times, then X would be 30 because that's the number of times I actually got the success. I actually got the heads. Whereas the probability is 0.5, 1/2, half heads, half tails. I'll write all this out in a minute. I'm just kind of showing the difference. The probability, which is P, is going to be that number between 0 and 1, whereas X is the actual number of successes. Okay, and then now, new, we have Q, which is the probability of failure. So we know probability adds up to 1. We know there's only 2 things happening because we're talking about binomial distribution. So if it's half is the probability of success for heads, that means half is the probability of success for tails because it has to add up to 1. If I did something totally different than flipping a coin, I don't know. I drew a number out of a hat or something, and I had 1/3 was the probability of a success, then 2/3 would be the probability of a failure because the 2 things have to add up to 1. Everything in this box we're going to review on the second page. Let's just take a minute and review these rules right here, these first 4 rules, and then we'll come back to this box and review it. Okay, so we're just looking at some examples to see if they result in a binomial distribution. So first, we're going to survey 12 jurors, and we're going to write down if they say no, and that's what that's the whole experiment. So is this a binomial distribution? Well, looking at the rules, it has a fixed number of trials. There's 12 jurors. Let me just kind of write this down as we go. So I'll just say they're labeled 1, 2, 3, 4 up there. So I'll just label them the same way. 1, fixed, has fixed number of trials. In this example, it's 12 because there's 12 jurors. There's 12 people they're asking. All right, number 2, it says that the trials must be independent. And so we say yes, because each person answers on their own. You know how they do like the little write it on a piece of paper, like the secret vote type of thing when they're doing the jury trial. So that means this person's answer is not affected by this person's answer. They're each answering on their own. So yes, that works for number 2. Number 3, the trials, each trial must have outcome as success or failure. Now here we're recording where there's a no vote. So here we have no is our success, because that's what we're looking. It says it in the problem. We're looking to see if there's a no vote. And so that this one, there is a success or failure. So yes would equal a failure. There's only the 2 choices. When you're voting in a jury, you can't say maybe guilty. You either say yes or you say no. So there's 2. And again, in this one, no is defined as the success because that's what it says in the problem. All right, the probability of success remains the same. So yes, yes and no are equally likely. You know, each person comes in with their opportunity to say yes or no. We don't have anything. We're assuming everything's fair and right and all that good stuff. We're not being shady in these examples. Okay, so I thought it went away. Okay, part B, different experiment. We're going around to 250 different families and we're recording the number of children. So we can kind of estimate what the question might be in this example. We would say something like, how many children do you have in your family? And so we're going to go ahead and write down those results. And so I don't need to go through all of these examples. This one, it's going to has more than 2 outcomes, because we don't need to go through all the steps 1, 2, 3, and 4 when we already know it fails. It already has more than 2 outcomes. Because if the question is how many children are in your family, people are going to answer 0. They're going to say 1, 2, 3, 4, right? Like they're going to just keep on going. People are going to have any number answer for their family. Now, if the question was different, if the question said, are there children in your family? That's a yes or no question. There's 2 answers. So we would be in a different situation. But this just says they're writing down the number of children, and that could be any number. There's more than 2 choices for this. So the conclusion we're making is this is not a binomial distribution. So just as a reminder, if something is true, then it has to be true everywhere. If something is false, it just has to fail 1 time and it's out. So this one failed right there. Okay, now let's go back to this formula right here. We're going to start practicing the letters and then we'll start using the buttons. Okay, so right here we have the question. An adult is randomly selected and there is a 0.5 probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 of 5 randomly selected adults knows of Twitter. All right, I'm going to pause this video real quick to get my children to stop talking in the background, and I will be right back. All right, I am back. So let me get back to my screen. And here we go. Oops, that is not the screen I meant to share. Let's try this one more time. Here we go. Perfect. Okay, so what we have is the question says, is this a result of a binomial distribution? So the question we're asking is, do you know what Twitter is? Have you heard of Twitter? Something along those lines. So the answer is yes, or the answer is no. That is a binomial, or I guess the answer to this question would be yes, because there's 2 choices. 2 choices. On the question that's being asked, the Do you know what Twitter is? Yes or no. There's two choices. So this is the binomial distribution. All right, now this one is not asking you to find any probability. It's just asking you to find these values right here. And the reason I'm emphasizing this, make a little note off to the side that just says something like, read the question. And what I mean by that is on the homework and on the test, sometimes the question says find the probability. And sometimes the question just says find the values of n, x, p, or q. We might give you something like that. And then people will answer the probability. They'll do all this work and they just needed to find a few values without any calculations. So make a note of it, like double check homework or double check the quiz question, something along those lines. Okay, so here we're finding these values. And so in the problem, n is going to equal the number of people total, the total number of numbers. So they asked 5 adults. 5 is the total number. It's not a very big number, but it's a number. Okay, X is how many were a success. So it's asking for the probability that 3 know about Twitter. So in this case, a success is that you know about Twitter. And so we know that there are 3. Now I'm just going to write down here, success equals knows about Twitter, or, answers yes, something along those lines, affirmative. That's what a success is in this problem. So that way, when we get to P, so X and P kind of go together. Once you figure out what a success is, X is how many people, like the raw data, how many people said yes. P is what is the probability that they said yes. What's the probability of a success? So in this question, it says in the very first line, there is a 0.85 probability that the person knows what Twitter is. So voila, we have our P. Feels like we've used all the numbers in the problem. However, to do Q, Q is the rest of it that adds up to 1. So the probability distribution always has to add up to 1 for reasons we've talked about many times. And here there's only 2 choices, success or failure. So if I want to know the rest of it, I just subtract from 1 and I get 0.15. Now you might know that without actually, well, the double minus sign, I forgot to delete it before I clicked finalize. What was I going to say? You might have just known it was 0.15 because like just dealing with change or whatnot, that's fine. But I like to write out the formulas at the beginning just to make sure everyone gets the hang of it. All right, so where did that Q formula come from with that weird minus sign? Typo. Right here, it's highlighted 1 minus P equals Q. So I did 1 minus 0.85 to get Q. Okay. Let's practice it one more time. And then we're going to actually put them in our calculators. It says find the values and find the probability. So we're going to find everything here. Okay, so here we have how many babies? There's 5 babies altogether because n is the total number. X is a success. In this case, success is a girl because we're trying to find the probability of 2 girls. So the success is a girl. I might even write that down. Success equals a girl. Now it's not really, yay for dogs. Everybody's home from school today, so that's why. It's not really, it doesn't really matter what the success is. It just helps us figure out what the probability is. So we're never saying one's better than the other. We're just saying what is considered a success in this problem so we know which one's P and which one's Q. Okay, so the probability of having a girl, well, you're having a baby, it's a boy, it's a girl, so 0.5. Oopsies. Which means Q. Now you don't need to really write out the subtraction because you probably figured it out already, but I like to write down the formula. 1 minus a half equals a half. Okay, we have all of our letters. Now let's find the probability. So we're going to say the probability of 2. We're trying to find the probability of 2 girls. And we're going to go back to this formula right here. We're going to take everything in the box. We're going to use, it's going to be fabulous. I'm going to write it all out and then we'll jump over to the calculator to see how to enter it in. But this NCR button takes care of this whole yucky fraction. P to the X, Q to the N minus X. All right, so this is what's going in our calculator. So NCR means we put our N first, which is 5. then I'm just going to put this in parentheses. This is the calculator button we're going to push. That's not really a times. That actually, let me put it in brackets so it looks less like times. There, I put it in a weird symbol so we know that it means put it in your calculator. And then R, it says R on your calculator. We're going to use X. So notice the N comes first on the calculator button. So I put the N at the beginning. This does not matter what kind of calculator you have. This is how you type it in. So we put the N at the beginning, and then the R, or in our case, X, comes at the end. So I put the X at the end. I put 2 at the end. And then I'm going to multiply by P to the X and Q. And we have to put parentheses when we type it in our calculator because we want to have the whole thing to the N minus X. Okay, so that is exactly what it's going to look like when you type it in your calculator. It doesn't matter what calculator you have. So let's type. So you can go back in on your notes if this is all kind of seeming like I jumped out of the blue here. You could go in with your notes and write out, let me see if I could write it above it. The formula, just so we remember what it is. It's N, and then the NCR button, and then our X value, times P to the X times Q to the parentheses N minus X. So you can kind of see where everything lines up. This top part here, let me see if I can highlight it. It doesn't like to highlight that, right? That part is going to be used repeatedly. We're going to use that every time, and then we're going to put in the specific numbers for each problem. So this, I'll highlight it with a box. That is the formula that we're going to use, written out in a way that looks exactly like we're going to put it in the calculator. All right, I said calculator enough times. Oops, making random boxes. Let me switch over to my calculator, which is right here. Okay, so we can clear off anything that we're not using. So we said, first we're going to type in N. There's my 5. Then I'm going to hit the NCR button. So it's right by your factorial, no matter what calculator you have. So here it's by the probability, on the probability button. Here is our factorial. NCR is number 2. It's the one with the C. So it's number 2. And then if you have a graphing calculator, you're just going to hit math and you're going to go over to probability. You probably saw it already. It's similar. It's right above the exclamation point. So if you can get to your factorial button, you can get to your NCR button. All right. And then 2. I feel like I already pushed 2, but it didn't show up. Okay. 5 NCR 2. Now I'm going to do times. So this is just like how I wrote it out on the notes. P, which was, and you might want to put parentheses sometimes. You don't really need to, it won't affect the answer, but if there's like other stuff going on, you might want to put parentheses. But we have 5 to the X power, so 5 to the 2nd power. And I hit this little caret. That's the symbol that I wrote out on the notes. And then notice my exponent is, or my cursor is up with the exponent. So I need to get away. So I hit over, and now I have the big cursor again. I can hit times Q, little caret, and then parentheses N minus X, 5 minus 3. One thing you might do, if you're getting mixed up with the exponents, 5 minus 2, that's 3. So you don't literally have to write 5 minus 2. You could do the subtraction in your head and you could write 3 up there. That way you don't have to mess with parentheses. It's up to you. But either way, however you type it in, that's the answer you should be getting, 0.3125. So you can see, well, you can't see everything I wrote in. You can see much of what I wrote in. This first part, 5, that's my N, and then the NCR button, and then 2. I will tell you, some people, if you have a newer graphing calculator, it kind of shrinks down and it makes like a tiny 5 and a big C and a tiny 2. That's okay. It all works out. This one doesn't do that. If you've seen it, don't worry. And if you don't know what I'm talking about, definitely don't worry. But this is the final answer we should be getting. If you need to rewind that, try it again on your calculator if you're not getting what I'm saying. And oops, didn't mean to show my face so large, but here we have our final answer for P of 2 equals 0.3125. And that is how we get it, just dumping it into our calculator using what I highlighted here. What I highlighted here is the calculator version of this whole formula. Remember, the part in the box here was just the N, that just took over the NCR part, but we still have the P to the X times Q to the N minus X. Okay, we are going, oh, that is not where we're going. We're going to back to page 2. We're going to look at number 4. And here, I'm going to change this problem just a little bit because we are going to talk about this in a better way in another example. So I'm just going to take out the word at least. Oh, golly. Looks like I censored it. That is the biggest line I have. That was supposed to be a straight line. Okay, well, there we go. That's what I wanted. That's what I wanted to happen. So there we go. We wanted to say getting 3 adults. I did not need the world's largest black box, but that's okay. All right, so here we are back at Twitter. We know, given that there's a probability of any given adult knowing of Twitter, 0.85, we want to find the probability of getting 3 adults out of the 5. So that brings us back to this problem right here. So we're going to use these numbers. It's the same problem. We're just actually finding the probability this time of number 2 now that we know how to use the calculator. Okay, so we've already written out, I'm just going to write it again because my screen has moved, my screen moves the stuff. But we know from problem 2 that there's 5 people total. We know that 3 of them know about Twitter in this example. We know that P, the probability of success was 0.85, which meant Q, the probability of failure was 0.15. Again, this is all just copying down what we already wrote above in example 2. So now we want to use our new formula. And I'm going to put in the probability, capital P, probability of getting a 3, exactly how we're going to type it into the calculator. So the probability of 3 adults knowing what Twitter is, we're going to start off with N. We are going to then type in the NCR button and finish up with our X. So we have the N in front, just like the calculator button says, and then they have the R on the calculator because we can't change it. We call it X at the end. Then we're going to multiply that times P. I didn't mean to literally write a P, but our P raised to the X power times Q raised to the N minus X. Now, N minus X is 5 minus 3. I know that's 2. So I'm just going to type in 2 when I get to the calculator. Okay, so let's switch over to the calculator. We're going to type all that in. So we have 5. Going to go to probability to use that NCR button. 3. Oh, that's where my, okay, never mind. I'm talking about okay. Times the probability of a success raised to the 3rd power. Now, if I forget and I just start typing in times Q times, and then, oh wait, see how it's all tiny up there? That's how I know I messed up. So let me delete. And then I need to go over to make the cursor big again and hit times. And now I'm going to do Q. We said it was 5 minus 3, but I could just type in 2 because that's what 5 minus 3 is. So last time I did it with the whole thing in parentheses. This time I just did it with that one answer. It will always be a very simple subtraction problem for that exponent. So it might just be easier to get into the habit of doing the subtraction first and then just writing in the answer. All right, so the probability that 3 adults out of the 5 know about Twitter is, and here we have our probability. It looks like I typed everything in the correct way. So here we have, so what we're trying to, we're not saying like only 3 people know about it. or we want to know the probability that exactly 3 people know about Twitter. So we did 5, and then we did the NCR button with 3 because 3 was our success. And then we did our probability of, I guess I could be walking through these numbers while we're doing it. No, I don't even know where my cursor is anymore. Okay, never mind. Here we go. This is what I meant to do. I'm so used to actually using my calculator that I forget what buttons I push sometimes. Okay. 0.85, which was our success to the 3rd power because we had 3 successes. And then 0.15 to the failures, which would be 2 would be the failures. So we're trying to figure out what's the probability that 3 people know what Twitter is and 2 people don't know what Twitter is in this group of 5. All right, then we hit our answer, and I've already shown the answer like 3 times, so we know what the answer is. Okay, 0.1382. Typically, probabilities were into 4 decimal places. It doesn't really matter why right now. It's just the rule. Once we get to chapter 6, you're going to see it so much that it's going to make a lot more sense why it is the way it is. It has to do with tables and charts that we're going to get to in the future, but that's just common practice for mostly for if we need to round for probability, we typically do to 4. So this would be 0.1382 would be the answer here. Okay, so I'm going to write that down. Over here, we have 0.138. Okay, so we've done a couple problems where we're just, so this is the plug and chug chapter. Identify the, this is what I said at the beginning, identify the variables, throw it in your calculator. So we just want to practice that plug and chug over and over again to get the hang of it so you know what goes where. This last problem, it's in bold, but I'm going to highlight it too. Same idea. We got the 0.85 on the Twitter and whatnot, but we want to know the probability that at least 1 person knows about Twitter out of 5. So at least 1 means 1 person out of 5, 2 people out of 5, 3 people out of 5, 4 people out of 5, or 5 people out of 5 know what Twitter is. That's what at least 1 is. 1 or more know about Twitter. What did I just say? 5 things, right? One person, 2 people, 3 people, 4 people, 5 people. That's 5 different probability problems. No, ain't no way. I'm not doing 5 different probability problems. So there's a faster way. When it says at least 1, that can be summarized a little bit differently. So the probability of at least 1 is the same thing as saying everything, all the opportunities, which is 1, right? So all the probabilities add up to 1, minus the only thing that I don't want. So if I say at least 1 out of 5, that means 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, 5 out of 5. Which one am I missing? I'm missing what I don't want to include is 0 out of 5. I don't want the situation where nobody knows about Twitter. So I am going to subtract out the I'm going to subtract out the probability that 0 people know about Twitter. So let me say that again. I know the probability of all of my choices, whatever my numbers are for X, is 1 whole, because that's the sum of the probabilities. Like it was literally a test question on the last test, well, so to speak. I want everything 1 except, which means subtraction, 0. I want everything except 0, 1 minus the probability of 0, which is so much better because now I just need to find the probability of 0. I don't need to find all 5 probabilities and then add them all together. I just need to find the probability of 0 and do 1 minus that. So I am going to, and 0, and it sounds pretty easy to find, right? Let's figure out what, let's see, wrong button. Let's figure out what the probability of 0 is. So the probability that 0 will know about Twitter. It's not 0. I'll tell you that. It's not going to be 0, but it's going to be the smallest number because it's only 1 out of, it's going to be a pretty small number. Anyways, the probability that nobody knows about Twitter. So there's 5. So we're doing this, you know, we're doing the same Twitter example with the 5 people. NCR 0, because our X is 0. So we want the probability of 0. That's going to be our X. And then we're going to do P to the x 0, p to the 0 power times, we can do to the 0 power. It's allowed. It just means that the answer's, anything to the 0 power is 1. So it's fine to have it to the 0 power. Q, same Q, to the n minus x power. Again, I told you it would be simple subtraction for that exponent, so we can just type in 5. So in this example, maybe I just kind of assumed that you knew what these were, but I guess I should write them out because we had already done a couple of these already. We had already done P and Q, but we didn't do our X. So N is 5. So there's 5 people. We want X to equal 0 because we're saying the probability of 0. P is 0.85. Q is therefore 0.15. Okay. Off to the calculator. So I'm going to switch over. I don't know why sometimes it just lets me switch and sometimes it makes me put my face back in the middle. Okay, last one. So I'm going to go here. It's a mess. I'm just going to clear it all out. And so I have 5 NCR 0, because X is 0, times P to the 0. If you know any of these things you already know, like if you already know P to the 0 is 1, then just type in 1. That's fine. You don't have to type it all in if you don't need to. And then times Q to the n minus x, 5 minus 0, which is just 5. I'm expecting a small number. Ooh, I got a real small number. Okay. This is where the magic happens. This is why I love that I have this app, because I can show you cool things better. I don't want to write that number down. It's too tiny. It's like super tiny. Am I going to round it wrong? What's happening? It's super tiny. So what I want to do, I know that the probability is 1 minus that number. It's backwards. It's over here. Anyways, whatever. It's 1 minus that number. So I just have to tell the calculator, do 1 minus that number, and I will have the answer. I don't have to write it. I don't have to write that long number down. So this is how you do it. You say 1 minus, to get that number, if I just go up, see that number? If I hit enter, it's going to copy and paste it for me. Magic. So 1 minus that number, I hit enter, and there it is. 0.9999 would be to 4 decimal places. That's it. And so I didn't have to write that number down accidentally. You know how there's 4 zeros and then you accidentally write down 3 when you're copying it down because you make a mistake. Like, we don't have to make a mistake because we just copied and paste. I'm going to show you again because it doesn't matter that I did a different problem. I can do that same problem again. I could do 1 minus, and then I just go back and find, just go up and say, what did I want to subtract? Oh, I want to subtract that number, copy and paste it by hitting enter. And I could do the same thing again. So it doesn't matter that I did another problem in between. I can go back up and find the number that I want and copy and paste it. All right, let's go back. Last time of switching, we found out that that probability that we were searching for up here. So let me just write this out again. The probability of at least 1, which equals 1 minus the probability of 0, was equal in this problem to 0.9999, because we typed this whole part up here already into our calculator, and then we plugged that in to the 1 minus, and we got our final answer. So actually, I don't want to highlight that because that is not my final answer. We should be highlighting our final answer, not just random answers that we see. So this right here is our final answer. Oh, I could have deleted it if I wanted to. Magic. Okay. Let me know if you have any calculator questions, any probability questions, any chapter 4 questions, any of that. Let me know, email, inbox, whatever, and I will be back in another video. All right, bye.